This section is 1.2 on functions. So we're going to start with some vocabulary, starting with relation, pairs of quantities that are related to each other by some rule of correspondence. So some x and y that have a rule that creates one another. A function goes a little bit further, so it is still a relation, but it has more to the definition. It assigns each element of x to an element of y. So every x, everything you put in, only has one thing that can come out from it. Domain is all of our set of inputs, what we put in, x values, and range is all the set of outputs, what we get out, our y values. So I like to think of this like a function machine. So what makes a relation a function? Every x has one y. Two x's can have the same y, but two y's will not have the same x. So whatever we put in here, let's say we put a 2, if we get out a 3, that means every time we put 2 into the machine, we will get out 3, never something different. Let's say we put in a 1 and we get out a 3, that's still a function, that's okay. We put in something different and got out the same thing, but we didn't put in a 2 and get a different number. There's 4 ways to represent functions. Verbally is by a sentence that describes the relationship of input to output values. Numerically is in a table or list of ordered pairs. Graphically is on a coordinate plane. You can plot the points using x and y on a graph. And algebraically is by an equation in 2 variables. We usually use x and y. So how to tell if something is a function algebraically, y has to have an odd power or an odd exponent. So 1, 3, 5, and so on. If it has an even exponent, it is not a function. Numerically, we look for repeated x values to make sure they're going to the same y value, because you'll never have 2 of the same x going to different y's. Graphically, we do the vertical line test. So a vertical line goes up and down like this. So we want to make sure if we draw a vertical line on our graph, it only passes the function once. If it passes more than one or crosses over it more than once, not a function. So we're going to do a couple examples to tell if it's a function or not. The first one is a table of values. So we look for repeated x values. Here we have 2 twice. So 2 goes to 10 and 2 goes to 11. Not a function because x has to go to the same thing if it's the same number. For a graph, we do the vertical line test. If I draw a line up and down vertically, I only cross it once. So here, crossed it, and I don't cross it again. I can do it here, crossed it, don't cross it again. So yes, it is a function. Algebraically, we look at y to make sure it has an odd exponent. Y without an exponent means it's y to the first. 1 is an odd number, so yes, this is a function. Here, these ordered pairs, none of the x values repeat, so therefore it is a function. Here, we have ordered pairs, none of the x values repeat, they all go to their own y, so yes, it is a function. Here, x values, 1 repeats, 1 is going to 2, 1 goes to 5, so it has different y values for the same x, not a function. For this graph, I draw the vertical line, I passed it once, and now I pass it again, so not a function. Here we have this x value 1 going to 0 and 15, not a function. On this graph, I'll do a vertical line test through all the points. Passed it once, 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 and once. So yes, it is a function. In this equation, looking at y has an even exponent, so not a function. And those are some examples. So moving on to function notation, this is where instead of writing an equation with x and y, we use x as our input, but f of x as our output. And so that's how you say this, f of x, not f parentheses x or fx. We say f of x. And so you can think of f of x as our new y value. So instead of having y equals x minus 1, we write it f of x equals x minus 1, and it's saying the same thing. So to evaluate a function, let's say a f of 2 now. So we say f of 2 because we don't have an x in the parentheses now, we have a 2. We would look at this equation here because we're talking about the f function. So you always look at the letter in front to tell which function to use. So this one we're using f, here we would use the g function, and here we would use the g function. So we're going to move on to the next slide and do these examples. So taking a look at the first example, f of 2, whenever we find these values, we want to take our f function, and anywhere you see an x, I like to put a parenthesis. So parenthesis squared minus 4 times parenthesis plus 7. And then we fill the parentheses in with whatever is in this parenthesis, which happens to be a 2. So when we solve, we do exponents first. So 4 minus, we can multiply 4 times 2, which is 8. And then we have plus 7. And then lastly, we'll simplify. So 4 minus 8, we get negative 4 plus 7. And last step, negative 4 plus 7 gives us 3. So f of 2 equals 3. Moving on to this one, now it's g of negative 3. So g is telling us we use the g function. We're going to do the same thing. Anywhere we see an x is going to become a parenthesis. And now we're going to fill in this parenthesis with what's in this parenthesis. And then we're going to simplify it using order of operations. So we have negative 3 squared is positive 9 plus 2, which gives us negative 7. So g of negative 3 equals negative 7. Our last example is a little different because in parentheses, we don't have a number. We have x plus 2. We're going to start it the same way, drawing a parenthesis wherever we see an x. And for this one, we're going to put x plus 2 in our parenthesis. Okay, so we have a little bit more room here. So now this squared right here is not saying we distribute the squared to the x and the 2. We actually have to FOIL. So what we're going to do, we're going to keep the negative. I'm going to put a bracket, and we're going to multiply x plus 2 times x plus 2 because that's what x plus 2 squared means. So to FOIL, we'll get x squared plus 2x plus 2x plus 4. And that's all in our bracket because all of this stuff is going to end up being negative because we have the negative on the outside. So if we distribute the negative, we can combine these like terms. This becomes 4x altogether. So it becomes negative x squared minus 4x because when we combine, it's plus and distribute the negative. And then minus 4. And we have that plus 2 on the end. And our last step is going to be to combine these two. So our final answer is negative x squared minus 4x minus 2.